An airplane flying with the wind takes 3 hours with a 45 mile per hour tailwind to reach its destination. The return trip takes 6 hours flying against the wind. What is the speed of the airplane in still air? So this one, pretty much the same thing. And I don't know, this one is, if I remember right, does not actually have boxes that you need to fill in, but we do need that original formula, right? We do need to remember that distance equals rate times the time. So we have the two values. We have an airplane flying with the wind. So we have the trip that goes with the wind, and then we have the return trip. I believe that the return trip is against the wind. Okay. Now, what we know about these two in terms of the distance, because it is the same trip, they would be equivalent to each other. But again, we can't write these in terms of the rate times the time. So that's what I'm going to do. I'll do with the wind in red and then against the wind in purple. And for those of you that have music playing in your head now that I said against the wind, I get it. But here with our rate, right, so we got with the wind, what did it say? It took, I guess I'm starting with the rate. So we have for the rate, we have the speed of the airplane in still air, but it's adding the tailwind value, which is the 45 miles per hour. Okay, so that's my overall rate here. I'm using R. Maybe I should have used X so it's not confused with the original rate. But yeah, that 45 mile per hour tailwind, that was expressed here in the problem. So when we come back for the return trip, that 45 miles per hour is now against us, okay? So we're going to take this rate for against the wind. If it'll let me. It's not the most efficient way, but it works. So let's fill in this rate right here. So again, we have the rate of the airplane in still air, but now that 45 is going to work against us. So it'd be minus 45 right there. And then we have the two times as well. So the time with the wind was 3 hours. The time against the wind was 6 hours. So let's get those replaced as well. This is with the wind, and that will be 3 hours. And then against the wind, which is 6 hours. Okay. Well, now we have the equation. This is the equation set up. It's only got one variable, and it's the variable we're trying to solve for. That's the speed of the airplane. So I'll distribute the 3. That's 3R plus 120. Thank you. And then that would equal distributing the 6. 6R. All right, then 6 times negative 45, that'd be negative 270. All right, so again, just like we saw in that last problem, we're now at the point where we can just solve this equation. So I'm going to use two principles of equality. I got my r's on the left, numbers on the right. So I need to zero out this 135, so I'm subtracting 135 from both sides. But the 6r also is on the wrong side, so I got to zero that out by subtracting 6r there. So now we got negative 3r's on the left. That's 3r's minus 6r's. The 135 zeroes out as planned. 6r minus 6r zeroes out as planned. And negative 270 minus 135 is negative 405. So again, we're at the point where it should be pretty easy to solve here. So let's go ahead and finish solving this for our rate. Yeah, I guess I'll do it in black here. So divide both sides by negative 3. And then the rate here appears to be 135. Yeah, that's positive, by the way. Okay, so that's the speed of the plane in still air. What was the rate? I can see up here is in miles per hour. So I'll just label that 135 miles per hour. That's it.